This is section 2.6, part 3. This is a slightly different type of problem. It is technically not a ratio. Technically, these are rates, but they are incredibly useful problems and they're very similar. This is something we use every time we go to the grocery store if you're on any kind of budget. You want to buy the best buy of whatever it is. Sometimes it's cheaper to buy, for example, if you're buying sodas, 2 12-packs than it is to buy a 24-pack. Something like that. So finding the best buy is a very useful skill. Some grocery stores do this for you. They print the unit price on the tag. Some grocery stores calculate them incorrectly to try to trick you. Some grocery stores don't do it at all. So it is important that you know how to do it. What we're going to do is right now we are comparing breakfast cereal. We have 3 different sizes available at 3 different prices. We want the most cereal for our money, right? So what we're going to do is we're going to find what we call the unit cost. What we're going to do is we're going to find out how much we are spending for each ounce. And then if we know how much we're spending for each ounce, then we can figure out which one is the best buy. Whichever one we're paying the least amount per ounce, that's the one we want to get. Now all you have to do here is several divisions, okay? What I want to do is for this one, I have 13 ounces. My cost is $2.80. I do that division, okay? 2.8, 0 if you want it, divided by 13. You're often going to get some ugly decimals. What you do want to keep a couple of digits more than you think, because sometimes the unit prices are very close together for each option, and you want to make sure you have enough digits to compare. So what I just found out is that for this buy, for the 13 ounce, I'm paying about 21.5 cents per ounce. Okay? Now let's check this one. 15 divided into $3.15. 15 ounces at $3.15. 3.15 divided by, what did I say, 15? Is 0.21. So on this option, I'm only paying 21 cents an ounce. Here I'm paying about 21.5 cents an ounce. I'm just going to put a simple mark through that because that's definitely not the best buy. Now, realistically, you don't want to mark it out so much that you can't see it. Definitely on a paper test, if I were grading a paper test, I would not want you to mark it out so that I couldn't see it. You just make a mark saying, all right, that's not my answer, and then you go on. Now let's try this one. Okay, 18 divided into 3.98. 3.98 divided, not times, divided by 18. 0.221111. So for this option, I'm paying more than 22 cents an ounce. This one is a better buy than this one, which is definitely means this is the best buy. Your 15 ounce is the one that you should purchase. Okay, so let's talk about an application of ratios. We'll talk about proportions. We have a proportion when 2 ratios are equivalent. When we're given a certain ratio, we can calculate different parts of it. So if we have 2 fractions available, then A times D is equal to B times C. When you have one fraction equal to another fraction, we can cross multiply and they're equal. When you first learned fractions, you may have learned a butterfly like that, and you multiply to see if they were equal. We're doing the same thing, it's just we're going to have some variables in there. Okay? So, let's look at one. Solve for the given variable. Okay? I have 49 over 56 equals z over 8. Now this particular fraction we could reduce and find z very quickly. The majority of the problems we work, we're not going to have that as a good option. So let's talk about how to do this. You want to cross multiply. It does not matter which direction you multiply first. I tend to like my variable on the left. I have a tendency to, if it's easy to do, I multiply so that my variable ends up in the left. So 56 times z, 56z equals 49 times 8 is 392. And this was 49 times 8. Now to solve this, I need to divide both sides by a 56. And when I do that, when I divide by 56, I get a 7. So this needs to be a 7. Now if you look at what I was talking about, if I enter 49 over 56, it reduces to 7/8. Since that denominator is that denominator, I could have gotten it very quickly. Okay?